Hi there everyone, today we are going to be looking at differentiation. Specifically this is for iGCSE, but it can also be kind of used for AS level maths as well. Alright, so we're going to look at differentiating an equation, what that's all about, and then we're going to look at how that is used for gradients and how we can use that to find a coordinate of a given gradient, essentially. Okay, so what is differentiation? Right, so differentiation is really just a process to find a function which allows you to calculate the gradient of a tangent at any point along a curve. All right, so really it's focused about a function which obviously changes gradient along the way, and differentiation is the process which you use to determine those gradients, if that makes sense. All right, probably best look at the notation so you're familiar with it. So when we've differentiated a term, you multiply it by the power and then subtract 1 from the power, and the notation we often see is this dy by dx. All right, so here you can see this dy by dx. All right, so in terms of what that kind of means, we're differentiating with y with respect to x. Okay, so what we're going to do, I'm just going to show you the notation. So if you've got y equals x to the power something, well, when we differentiate it, we write this dy by dx. So we're differentiating y with respect to x, dy by dx, equals n. So the power is multiplied, right? So we bring the power down to the front, and then x to the n minus 1, so the power is reduced by 1. Okay, we're going to show you, well, I'm going to show you a number of examples just so that you can see what that means in actual reality. All right, so if you're asked to differentiate y equals x to the power 4, we're going to bring the power to the front, multiply it by 4, and then reduce the power by 1. And so the differential, so the dy by dx for this particular equation is 4x cubed. So the 4's come to the front and we've reduced the power by 1. And that's the same for all these kind of things. But when you differentiate, you do each term separately. All right, so what would it look like for 6x cubed? Well, we're going to multiply this front bit by 3. So that's going to become 18. And then we're going to reduce the power by 1 to 2, so that's going to give us 18x squared. And again, you can see the notation written down here, dy by dx. Well, what about if you've just got just an x on its own? Y equals 4x. Well, this is x to the power 1, so we're going to reduce the power by 1 again. All right, but obviously 1 times 4 is 4, so that's going to remain the same. And then we subtract the power. Well, that's going to be x to the 0. Well, as I'm sure you will know if you've done lessons on indices, anything to the power 0 is 1. So 4x to the 0 is 4 times 1, which is just 4. Or alternatively, the more you do this, the more you recognise that if you've just got 4 to the x, it's just going to become 4, essentially. Okay, that always kind of happens if it's just x on its own. What about if you've got y equals 5, i.e. there's no x's? Well, we can still differentiate with respect to x, but the problem is there is no x's. So we multiply the power 0, because it's x to the 0, so that's going to make basically nothing. When anything times 0 is 0, so dy by dx in this case it is just going to be 0. Essentially, if you think about the graph of y equals 5, that is a horizontal line. So there is no gradient to it, which is what this is telling you, essentially. So if you've just got a number on its own, it will literally disappear or become 0. All right. Well, once you've got more than one term, I kind of mentioned this a bit earlier, well, you are going to differentiate each part, this term and this term, separately. So the 3 is going to come to the front and multiply by 3, and that's going to give us 9x squared for the first part. And then when we do the 2x, well, like I just mentioned about a minute ago, this is going to become just 2. So we're going to have 9x squared plus 2, and that's going to be the differentiated term for that particular one. Well, what about something like this? Well, if you've kind of learnt from the previous one, you'll notice that this is going to come to the front. It's going to give us 16x, and it's just going to x to the 1, so just x, 16x, and the number will disappear. So we're just going to be left with 16x for that one. Okay, so that's differentiation, and that's how we do it. But I've mentioned about using it for tangents and gradients. So let's apply that a little bit. So let's look at gradients first of all. Well, if you want to find a gradient of a specific point on a curve, then we substitute the value of the x that we maybe be given into dy by dx, because what we've got is dy by dx is the gradient, but it's going to be in terms of x. So if we've got a coordinate, then we need to substitute the value of x into it. So let's have a look at this particular example. So if you've got a curve which has an equation of x cubed plus 4x squared minus 3x, now if you were going to plot that graph, it would probably change shape. It would probably go a little bit like that, up and down. So we need to find the gradient of the curve at a specific point, well in this case when x is 2. Alright, well there's no point in substituting the value of 2 into this, because all it will give you is the y coordinate. So yeah, it will give you the full coordinate, but it's not going to tell you the gradient, which is what we're after. So we differentiate. We differentiate the equation, which will give us the gradient, such as this. So when we differentiate this, we'll do it in 3 separate parts. So 3 is going to come to the front, and it's going to give us 3x squared, dropped by 1. The 2 is going to come to the front, it's going to come at 8x, and then the x is going to disappear, so it's going to be minus 3. So 3x squared plus 8x minus 3 is going to be our gradient. Okay, so that is an expression for our gradient, but of course we know what the value of x is. We'll be given it in the question. So at this point we substitute the value of x into this expression, which should give us a numerical value for our gradient, which we're going to do now. So you can see 3 times 2 squared plus 8 times 2, take away 3, which is going to give us 25. So the gradient of that equation when x equals 2 is 25, quite steep. Okay, let's have another look. Another one. The curve is given by the equation y equals 3x squared minus 2x, and find the gradient of the curve at a particular point. So this time it's slightly different, is that it said x equals 2 for this one. Well, this is no different really, other than x equals 3. We can kind of ignore the fact it's 21 again. That's just the full coordinate. We're going to use the value of x equals 3 again into the differentiated equation of this one. So as before, let's differentiate y equals 3x squared minus 2x. Well, the 2 is going to come to the front, and times by the 3 is going to give us 6. So 6x on its own. And then the 2, well, the x will disappear, so it's going to be 6x minus 2 when we differentiate it. And unlike last time, we're going to substitute the value of 3 into x, and we're going to get 6 times 3, which of course is 18, take away 2, it's going to give 16. So the gradient of that particular equation when x is 3, or at 321, is 16. All right, so that's how we do gradients. Well, what happens if we're trying to figure out where on a particular point a gradient is? All right, so here it says find a point when you have the gradient. All right, so if you want to find a point on the curve with a specific gradient, then you still need to differentiate it, but make that equal to the gradient and then solve it. So let's look at a couple of examples here. So the equation of the curve is y equals x squared minus 8x plus 2. I'm going to find the coordinate, again, keywords, not just the x value, the coordinate of the point on the curve where the gradient is 12. Okay, so when the gradient is 12. So what we've got here is an equation, first of all, not the gradient or an expression for the gradient. So we need an expression for the gradient first. So we're going to differentiate this. So we've got dy by dx, so the 2 is going to come to the front. And then you take away the 8, and of course the rest of the number is just going to disappear. So 2x minus 8 is the gradient, and we know now that that equals 12. So just make it equal to 12, and then solve. All right, so take the x, 8 minus 8 to the other side becomes 20, and divide by 2, and it's going to give us 10. So the x coordinate is 10, but do not forget it asks for the coordinate, not just the x value. So we now need to figure out what the y value is. Well, this is the differentiated version, so we're not going to touch this one. This is the equation that we're really focused on, where y equals this lot, because we want the y value. So we're going to substitute the x equals 10 into the original equation to determine y. Okay, so let's substitute that one in. So y is equal to 10 squared minus 8 times 10 plus 20 plus 2, which is going to be 100 minus 80 plus 2. Which is going to give us 22. So that's the y value. So the coordinate in this particular case is 10 and 22. So that's the coordinate for that. Or what happens if the equation is a little bit more complicated. Well, let's have a look at that one. It says at the bottom here, like you can see, don't take to work out the value of y by substituting x into the original equation. The reason we mention that and stress that is because what we tend to find is that when you substitute the value of x back in, it sometimes goes into the differentiated value. Of course, that's incorrect. And sometimes people just don't bother. They just don't look to find y because they think that's the end of it. All right. So hence we bolded those particular bits because we kind of recognise that that's where some people make the mistakes. So let's have a look at this final example. It's a little bit more complicated because we've got an x cubed. So when we differentiate this one, same process as before. When we differentiate it, we've got 3x squared minus 6x minus 12. Okay, so just differentiates, so 3 comes to the front, drops to 2. 2 comes to the front times by 3 is 6, and it's just 6x, and then obviously the x just drops off. Now we make that equal to 12, like we did before. A bit of rearranging, and it's going to give us 3x squared minus 6x minus 24 equals 0, and you might recognise this as being a quadratic, which it is, which is why I made it equal to 0. So we're now looking to solve a quadratic. Well, I can see from here that I have a common multiple of 3, so I can divide these by 3 first of all. I'm going to make it a little bit easier, which is going to give me x squared minus 2x minus 8, and then I'm going to have to decide whether or not I think this factorises or whether or not I can do it by some other means. Well, fortunately for us, that this does factorise. Okay, we've basically got 4 and 2, which gives us this, and then I've got minus 2. So it's going to factorise nice and neatly into x plus 2 and x minus 4, where it equals 0. And of course, that means I've got two values of x, where the gradient is 12, which suggests I therefore have two coordinates, where the gradient is 12. Okay, so I need to repeat what I did in the previous one, but I need to do it twice now. I need to substitute minus 2 into the original equation, then I need to substitute 4 into the original equation, and it's going to give me two coordinates where the gradient is 12. All right, so we'll start off with minus 2, and you can see from here it's minus 2 cubed minus 3 times minus 2 squared minus 12 times minus 2. And just be very, very careful. You'll notice I've put brackets around this lot when I've looked at the calculations, simply because you've got so many negatives taking place. I just want to make sure that I don't make a mistake. So you've got y equals 4. And then when you put the second one in, you've got 4 cubed minus 3 times 4 squared minus 12 times 4, and that gives me minus 32. So bringing all those together, so when x is minus 2, y is 4, so that's minus 2 and 4, and when I've got x is 4, y is minus 32, and that gives me the second coordinate. So I've got two coordinates where the gradient is 12 in this particular question. All right, so quite time consuming, quite an awful lot to do, but if step by step is the best way I can suggest you kind of work your way through these, as long as you're kind of aware of how to differentiate, how to solve equations, how to potentially solve quadratic equations, and then making sure that you find the final values of y's as well carefully by substituting them into the correct equation is the way to go.